Okay, I think we'll welcome everyone to the webinar one last time here, and hopefully as we continue, we'll probably get more people joining, but we're glad to have you today for our first Crop Hour webinar. And with us, we have Dr. Ken Hellevang. Dr. Hellevang is an Extension Ag and Biosystems Engineer at NDSU, so we forgive him for that because he knows a lot of topic matter. So we still like you, Ken, even though you're a Bison fan. He has a PhD degree in engineering, and he's a registered professional engineer. He's obtained the academic rank of tenured professor with NDSU. Ken focuses on education and technical assistance in grain drying and storage, structures with a focus on energy efficiency, indoor environmental engineering, and primarily related to moisture and mold, and flood preparation and recovery to farmers, citizens, and ag business professionals across the US and internationally. He's been doing this since 1980, and Ken is a wealth of knowledge to our region. There are not a lot of people who focus on his subject matter, so we're always grateful to have him with us at SDSU because he is definitely our regional expert, and he's been in this career path for a long time. He's obtained many academic awards, and he's currently serving as the interim chair of the NDSU Department of Ag and Biosystems Engineering. Him and his wife, Myrna, live in Fargo, and they have 3 adult children and 7 grandchildren. Sounds like a busy family, Ken. And one last tidbit, because I've worked with Ken a few times, I happen to know this. It isn't in his formal bio, but I think it's safe to share. Ken grew up on a livestock ranch in Northeast South Dakota near Sisseton. So his bachelor's and his master's are actually from NDSU, and he did teach in the SDSU Ag Engineering Department in 1979 and 1980. So a fun little tidbit about Ken, but without further ado, I'll let you take it away, Ken, and just a reminder to attendees that if you do have questions, please feel free to put them in the Q&A feature, and we will go over them at the end of his presentation.
Well, good morning, everyone. And yes, I did start out as a farm boy in Northeast South Dakota. Spent 6 years at South Dakota State University before straying north to North Dakota State University. But over the years, I've spent a lot of time in South Dakota as well as a number of other states because, as Sarah indicated, there unfortunately are not very many people that are focusing in on this topic area. So currently, not only do I stray a little bit south to South Dakota, but spend a fair amount of time working with Nebraska, some in Iowa, certainly Minnesota, and pretty much across the whole U.S. So we're going to focus today on what I have labeled as using aeration to manage stored grain through the seasons. Excuse me. As an engineer, I focus a lot on controlling the grain temperature and using fans to do that. But there's a lot of the need to understand how the storage environment in that grain has a huge impact on the storability. So we're going to run through a series of slides, and like Sarah said, be glad to take some questions at the end. I start out all my presentations with just a reminder that grain can be a hazardous situation. We've had a lot of attention recently of grain entrapment, but there are some other hazards as well that I want to just mention briefly. In years, particularly where we have damp grain going into storage, if it crusts, that bridging in there will transfer the load to the bin wall. And the bin wall is really only designed to handle a certain amount of load. And so this is a pretty graphic picture here in the upper left corner, but shows what can happen with some of that excessive loading. And then also I encourage people to be aware of the respiratory dangers of working around grain. that if we have moldy grain or even grain dust without mold, that is a respiratory hazard. And so encourage that people that are working around that grain do wear respiratory protection. Hopefully, most of you probably have seen a table like this that lists the approximate allowable storage time for cereal grains. It's up on my website, and it's a tool that I think is very helpful. It looks primarily at the amount of deterioration that is occurring during storage. Some of it due to respiration, some of it due to mold growth. But what we find is that once we've used up what we call the allowable storage time, typically there's enough quality loss that we're going to be penalized for that. And I'm going to use it to talk a little bit about corn. In South Dakota, corn production is a major crop. It used to be that the moisture standard was 15.5% moisture. So people were really targeting towards trying to store that corn at 15.5% moisture. But if we look at this table, and let's just go to 70 degrees, come down to the 15%, and we have about 125 days. At 16%, only about 70 days of allowable storage time. So while we could probably get by storing corn through the winter at 15.5, it really ends up being too wet for storage into the next summer, which we see as a very common practice today. So we need to get down to something closer to 14 or even below 14 to feel safe storing that corn through the summer without seeing significant deterioration. This next slide shows the same thing for soybeans. Um, this is looking at, again, the cereal part of the soybean, and I'll touch on the oil part in just a moment. But again, with soybeans, we're thinking of about a 13% moisture as the market moisture. Again, we come out to 70 degrees, and we're only looking at about 70 degrees days of allowable storage time. So where I've heard a lot of people say, well, soybeans are harder to store than corn. I think a lot of it relates to the moisture content that we're trying to store that grain at. If we go down to 12%, we're up to about 125 days, 11%, and we're out to 200 days. So I think again, 13% moisture is fine for soybeans that are just being stored through the cold winter months. But if we're thinking of storing them into the late spring and summer, we really need to be down to somewhere between 11 and 12%. And I'll show you a table that indicates we probably really need to be thinking of closer to 11. This table is an estimate that has been put together. It's not really based well on research. Um, we at NDSU are doing some research now, and there's a couple other locations that are looking at trying to really establish the allowable storage time for soybeans when we include the oil portion of it. And what we find is that the oil quality also is affected by temperature and moisture content. And so to maintain the oil quality, we really need to be down to somewhere in that 11 to 12% moisture if we're holding into the warmer months. When we look at storage, primarily what we're doing for most of our crops is trying to prevent mold growth. Mold growth occurs somewhere or starts somewhere in the neighborhoods of a relative humidity of about 70%. And if we look at this box of air up here in the upper left corner, at 70 degrees and 60% relative humidity, which would allow us to stay under that mold growth uh, window. We're looking at hardwood spring wheat ending up at a moisture content of 13.3%. That's what we call the equilibrium moisture content. The air in the wheat, you might say, is at the same moisture content. We could store that then for months and months under that environment and not expect mold growth to occur. So if we use that same criteria of 70 degrees, which is kind of a summer storage temperature, and 60% relative humidity, look at the equilibrium moisture content of the grain that we're working with. That should give us an indication of the moisture content that we need to be at. So if we come down here and look at corn, the equilibrium moisture content is 12.8%. And so really for long-term storage, we need to be in that 13.5% moisture range, similar to what we would use for storing wheat. If we look at soybeans, the equilibrium moisture content is 10.2. And so probably that 11% moisture is the moisture content we really need to be thinking about for long-term storage. I showed you that table in the previous slide. That's really a table that has been developed by trying to transfer what we know about corn and the cereal grains over to soybeans. Iowa State and I have visited quite a bit about the need to be really targeting more that 11% moisture, and that's typically the range that we're looking for today for summer storage. So if moisture is so important, I think it's important to make sure that we're getting an accurate measurement of that moisture content. Most of the meters that we use, whether they're the electronic, more farm scale, or the higher priced, what you might see at the elevator, tend to be influenced by a variety of things. We need to adjust for temperature. These electronic units are impacted not only by grain moisture, but by temperature. Most of the meters today are automatically measuring the temperature and making that adjustment. Some of the old ones, you had to go through and manually do that. But what we may forget is that they typically are going to have an accuracy window, you might say, of operating temperature. And for a lot of our meters, if the grain temperature is below 40 degrees, we're not going to get an accurate reading. I'm only aware of probably one or maybe two meters that can take us down below 32 degrees. And so really look at the moisture meter or tester that you're using and make sure that the grain temperature is within that operating range. If there's any moisture variation within the kernel, that's going to influence the accuracy. The outside of the kernel tends to influence the moisture reading more than the true moisture throughout. And so what I really recommend is that we put the sample in a sealed container, let it warm to roughly room temperature, Typically, this is going to be 6 to 8 hours to allow any moisture variations to equilibrate, and then check that moisture content. Um, at least we should do that with a sample periodically to see whether the meter is being fooled by some of the conditions of that grain that we're working with. Another management practice that I think most farmers today are aware of and use is that we don't want to be having a peak in the grain. That exposes a lot of surface area to being heated during warm temperatures. It tends to influence where the airflow goes with an aeration system. And then typically the majority of the fines and foreign material end up in that center core. And so recommended practice, and I think what a lot of people will do today, is fill that bin to the peak during harvest and then take out a few loads to core that bin and to level that bin. That I think is a huge factor in successfully storing grain. I talked to many farmers who say that they had problems until they started coring their bins. I put this visual together quite a number of years ago to illustrate the storage management practices throughout the season. We started out by looking at different temperature ranges. 70 degrees and up is just optimum for insects and spoilage. In that 50 to 70 degree window, insect reproduction is reduced. We get below 50 degrees and insects go into dormancy, and below roughly 30 degrees, we can actually kill insects if they are kept at that temperature for a period of time. The curved blue line is the average monthly temperature for North Dakota. It's going to be slightly different depending on where you're at in South Dakota, but we'll pretty much follow that same curve. So what the recommendation is to cool the stored grain whenever we have the opportunity during the fall. Whenever there's a 10 to 15 degree difference in temperature between average outdoor temperature and grain temperature, we should be running the aeration fan and bringing that temperature down. I recommend bringing it down to roughly that 20 to 25 degree window for winter storage. And then we'll talk a little bit more about aerating in the spring later. But typically we're going to need to do some aeration in the spring just to try to do some cooling of that grain to create some uniform temperatures again. But the goal should be to keep the temperature under 40 degrees and roughly that 35 to 40 degree temperature range for as long as we can going through the summer. Years and years ago, the recommendation used to be you cool the grain in the winter and you warm the grain in the summer. And that has not been a recommended practice for, like I said, a long time. But you still see that showing up in some of the guidelines that are out there. I just wanted to re-emphasize that we can control insects by regulating that grain temperature. This puts in a little more narrower windows what those different temperatures will do or what the impact will be on insects. So in that 75 to 90 degree temperature range, that's optimum for insect reproduction. We want to stay away from that temperature as much as we can. we get down in that 55 to 75, insect activity is reduced. Get down below 37 to 41, insects are dormant. I rounded that off to below 50, rather than just saying that we're going to look at something around 40. And then if we cool the grain to that 14 to 32 degree range, the insects will actually die if held at that temperature for a period of a few weeks. So in our northern climate, I say that there's really no reason why we should have insect infestations in our stored grain until we get into the next summer. Just by controlling the temperature, we can control the insects. There will be a talk later on fumigation, but all that I'll mention is that I hear too many reports of when it was a little easier to get a hold of phostoxin or some of the fumigants to say, well, I've got a hot spot, I got insects in it, I want to put some fumigant in there. The fumigant does not volatilize well. You get partial control on the insects because some of them are dormant, some of them are active. And so generally, in order to fumigate, you need to have warm grain, which is not typical for our northern climate. So really recommend controlling insects with temperature throughout the storage period until we reach next summer. There's a fairly simple formula that we can use to determine how long it's going to take to run an aeration cycle through the bin. The temperature change will start at the bottom if we're pushing the air and gradually move its way on up through to the top. And we can estimate how long that will be by taking the number 15 and dividing it by whatever the airflow rate is. A very common airflow rate is 2/10 of a cubic foot per minute per bushel. And at that airflow rate, we can cool that bin in 75 hours, or roughly 3 days. And it doesn't take a huge fan to do that. And as an example, I've listed on a 42-foot diameter bin, 36 feet deep, that'll hold 40,000 bushels of soybeans. Just a 5-horse low-speed centrifugal fan would give us that 2/10 of a CFM per bushel airflow that we need, and we would cool that whole bin in 3 days. And so we're not talking, even on a pretty good sized farm bin, needing a huge fan in order to control insects and mold by controlling the temperature. I put this visual together just a few years ago to just remind people kind of what's taking place when we're running that aeration fan. We have at the bottom what I call a buffer zone. Temperatures are going to vary during the daytime. So we might typically see a 20-25 degree temperature difference between low and high. And so during the cooling period, we're going to end up with temperatures that are approaching that cold temperature. But then when we have warmer temperatures going through, it'll start warming that cold grain, but in doing so, cool off the air. So really what that grain mass really ends up seeing is something close to the average temperature. Now, if we get a huge weather change when we're running the aeration fan during that 3 days, then of course we're going to see a change in temperatures within that bin. But typically we're going to end up with the grain temperature being fairly close to the average temperature when we're running those aeration fans. Just this is a slide that I've used for many years with some modification to make it more current with today's bin sizes. But sometimes I think people forget just how economical running an aeration system might be. Again, I use a 42-foot diameter bin, 26 feet deep with corn. That puts us just under 29,000 bushels. We use an airflow rate of 0.2 of a CFM per bushel. Just a 3 horsepower fan will provide the airflow that we need through that 26 feet of corn. Even if we were to run the aeration cycle 12 times, and we were looking at electricity at a cost of 15 cents per kilowatt hour, that is less than 2 cents per bushel for the whole year to control insects and mold. And I always say that you're not going to find a better insurance policy than what we see here. Um, just for a minimal cost per bushel, we will have all kinds of benefits. On my website is a link to this program at the University of Minnesota that helps us in selecting the fan that we need to provide the airflow rate. So we put in the type of grain, the bin diameter, the grain depth, put in the desired airflow. If we're looking at 0.2 of a CFM per bushel, we would put in that airflow rate, and then it'll come back and calculate for you what the bushel capacity is, the airflow that would be needed, the estimated static pressure, which is the force that's required to get the air through the grain, and then an estimated fan horsepower. This is a good starting point. I always will take and use the bottom portion there where you can actually go in and select a fan, put it on that bin, and it'll show you in a table below what the airflow rate is going to actually be. And so if you have a fan on a bin and you want to determine, what kind of airflow rate am I getting, there's, I think, roughly 200 fans that are listed in that program, and select either your specific fan or one similar to it, and it'll give you a good estimate of what your airflow rate is through that bin. A few tips on when to run the fan and when not to run the fan. Ideally, we're just trying to change the temperature, and so there's no need to run the fan when it's snowing, when it's foggy or rain. Under those conditions, leave the fan off. Select the time when we have uh, decent weather, a nice, dry period to run the fan to change the temperature. If you do end up running the fan through a rain shower or for a little bit, it's not going to re-wet the whole bin. It'll be just a layer on the bottom, but we don't want to do that if we don't have to. We've had quite a number of bins where we end up with the bin vents icing over. That then allows the fan to develop pressure within the bin, and we ended up with a bin roof that is rounded, similar to what is shown there in the middle picture. It's likely going to happen when we're at temperatures near or below freezing. There's enough moisture frequently coming off of corn in particular that when it hits those vents, it starts frosting and then icing, and we'll seal up or ice over those vents. To prevent damaging the bin, I really recommend when we're running the fan at temperatures near or below freezing to leave the fill hole and the access door open as kind of a pressure relief valve. There are pressure switches that could be installed within the bin and wired into the electrical circuit. I don't see them used very much. So as the fail-safe method, you might say, when we're running those fans at those colder temperatures, let's leave the fill and access door open. I strongly recommend covering the fans when we're not running the fans. The little gopher there in that top picture was very busy carrying all kinds of debris into the aeration ductwork in this bin when I took the picture. Uh, Probably that's not as important as some of the snow and other things that might blow into an open fan. If we leave the fan open when it's foggy or when there's drifting, that air is going to be going into the bin, and many reports are of the only spoiled grain in the bin is on the bin floor. And I think it's because of those kinds of scenarios that we have that kind of problem. The other thing is that in the spring, if we have warm, moist air outside and we don't have those fans covered, we get a 20, 30 mile an hour wind blowing into that open fan. We're aerating the grain and we'll warm that grain typically to the daily maximum temperature. And so it's really critical from a storage standpoint that we get those fans covered when we're not operating them. As we start looking forward to spring conditions, we're going to start seeing more and more solar radiation hitting that bin. And what I've shown here is the amount of solar radiation hitting a bin on February 21 and June 21. If we look at the south wall on February 21, we have 1,725 BTUs of heat energy hitting that bin during a day. If we compare that to June, we've got more than twice as much heat energy hitting that south wall. Now that of course is due to the solar angle, but it also is going to be warming the grain next to the bin wall. It won't go in more than a couple feet, but it is adding heat to our stored grain. Same thing is true when we look at the bin roof, 1,800 BTUs on a bin roof, where in comparison to summer, of course, it's going to be higher because of the higher solar angle. So I think we need to consider that in addition to whatever the outside temperature is. So when we look at March, and again, these are North Dakota numbers, they'll be a couple degrees different for South Dakota. We're looking at temperatures of 25 degrees. So we can maybe run the fan in March just to start doing some of that cooling. April, average outdoor temperature 41. But if we look at nighttime, we're down to 29 degrees. So again, as we start looking at later into the spring, we may need to be selective of when we're running that fan to help cool that grain or keep it cool. Anybody that has been in the bin roof or in the top of a bin knows how much solar energy hits up there. And we need to make sure that we're not permitting that to warm our grain. Even as we get into May, average temperatures 55, but we do have some nighttime temperatures that would still allow us to cool that grain down to roughly the 40 degrees. So spring really needs to be an action time. We're busy thinking of planting next year's crop, but at the same time, we need to be managing that stored grain. As I indicated, I do presentations pretty much across the country. So I put together this table to really compare numbers in each of the different states. In North Dakota and South Dakota happen to be side by side. So when we look at particularly April conditions from an aeration standpoint, the minimum temperature in April for North Dakota is 29, South Dakota 34. So there is a difference, but not a whole lot. As we start looking at summer storage, I think we really need to be focusing on ventilating the headspace. When we think of all of the solar heat gain up there, it's going to be warming that grain on the top of the bin if we allow that heat to sit in the top of the bin. So I'm really encouraging people to either have a bin where we vent that headspace just like we would an attic on a building, on a house, where we have air coming in at the eave and out at the peak so that we get the natural convection buoyancy carrying that heat out. Or more and more we're seeing, particularly in some of the bigger bins, where we're installing fans on the bin roof to actually ventilate that headspace. And that's what's shown in the little picture in the upper left corner. Another strategy that I think we need to be thinking about for summer storage is that regardless of how much effort we put into ventilating the headspace, we are going to see the top warming up. And in this little sketch that I've got, I'm showing 40-degree grain in the lower part, but we've got a layer at 70 degrees at the top. If we are using that 2/10 of a CFM per bushel and we only want to cool about 3 feet of that 20-foot grain depth, we would need to run the fan about 11 hours. So what I'm recommending is maybe every 3 weeks or so, monitor, know what the temperature profile is, run the fan for a few hours at sunrise on a couple mornings to utilize the cool grain that we have to cool down that top surface. Don't run the fan any more than we need to because we don't want to add any more heat to the bottom of the bin than is necessary, but we can utilize some of that cool grain to cool down that top surface. A lot of times I start getting reports of insects in July, and I think some of that could be reduced by running the fans periodically end of June and into July to keep that surface cool. We've always talked about managing the grain, and I added this little definition up there a couple years back to include that we need to have some skill involved. We need to understand some of the things that I'm covering in this presentation if we're going to manage that bin correctly. Each year is going to be different, and so understanding the fundamentals allows us to then manage the grain the way we would want it managed. We need to be monitoring that storage, and typically we're looking at temperature, moisture, looking for insects, any mold that might be growing. We need to be checking, I think, at least every 2 weeks until we have it cool down for winter storage. During the coldest part of the winter, probably 2 to 3 weeks, and I'm guessing even 3 to 4 weeks may work, as long as we have cool grain starting that winter. But as things start warming up again in the spring, I think we need to be thinking of back to about every 2 weeks. And what we're doing is managing that grain by our aeration system. We may need to do some drying, we may need to do some other things, but if we're managing temperature and moisture, we can typically control the other problems that might surface. There are a number of tools available to help us with managing the grain. Everything from manual units that you plug in and measure temperatures to automatic systems that send the signal back to your computer and will trigger alarms. And I just caution that technology does not replace management. It's a tool that we can use, but it does not replace still checking on the grain and monitoring what's taking place. One of the reasons why I don't totally trust the system that are available is that grain is an excellent insulator. And so you get an insulation value of roughly 1 per inch. So you get 2 feet away from a temperature sensor, and you have an R24 isolating that area from the sensor. And so it used to be that we would see a picture kind of like what's in the right side of our slide. And I've put a big X through it because there's no way that it's really telling you the whole picture. We're doing spot checking in the bin, which tells us a lot. There's no way we would know what's taking place down within that grain mass if we didn't have the temperature sensors in there. But they don't tell us the whole story. And so again, use them as a tool. We have fully automated systems that will measure outside temperatures. They'll measure inside temperatures, make the decision to run the fan, and those will work. But again, with the same caveat that I labeled before, they don't replace your management. They're a tool that will help select when the fan is running, and it can do that. Years ago, we used to just wire up humidistats and thermometers and accomplish many of the same things. Today's technology is much more sophisticated, and it's a tool that I encourage people to use, but it's no better than doing it manually as long as we're doing the appropriate management that goes along with it. A relatively new thing for grain storage management is carbon dioxide. Carbon dioxide is the byproduct, of course, of insect activity, and it's also a byproduct of any spoilage that or mold growth that might be occurring. So a number of years ago, we started researching and looking at, can we get an indication of what's going on in the bin by monitoring what the carbon dioxide level is. Typical concentrations outside, this is 350 to 400. I've measured 450 pretty routinely as well. So, but it's something in that roughly 400 parts per million range. If we start getting a mold problem or an insect problem, we're going to see the amount of carbon dioxide go up. And kind of a target that we've listed that you start getting up around 1,000 parts per million or higher, that's an indication that maybe there's a mold problem that is starting. You get above that 1,500 and likely where there's some very severe spoilage taking place. Again, a tool that I don't see used very much in this area, but I think is something that we'll be seeing more of in the future. Just a few slides into the design of an aeration system, and then we'll close this off and open for questions. We developed a publication through the Midwest Plan Service, which is located at Iowa State, publication called Dry Grain Aeration System Design Handbook. And what we tried to do was to look at all the different components of a system on a bin and come up with recommended design parameters. I had the opportunity to be the lead author on that publication, and all of the co-authors that are listed here, unfortunately, are no longer with us. So when we start looking at the design of an aeration system, I think it's important that we look at all the different aspects. If we have, like they say, a weak link in a chain, that's going to cause us trouble. So we need the right airflow, we need the right fan, we need to think about the airflow distribution and uniformity throughout the grain mass. We need to think about and design the transition between the fan and the bin or ductwork. Sizing of the ductwork or the system is important. Sizing of the perforated area, and also the exhausts or intakes all have to be sized appropriately. And I'm just going to walk through these very quickly, but some of the rules of thumb that we use for dry grain aeration, typically we're at about 0.2 of a CFM per bushel or less, depending on the cooling time that we're targeting for. With wet grain holding, typically in the 0.2 to 0.5 CFM per bushel, and then natural air drying at least 0.75 to 1.25 CFM per bushel. A lot of times I hear aeration used as a term for all moving air through grain, and really each one needs to be designed and operated differently. And so I prefer, of course, the more accurate nomenclature. Sizing of the perforations in the floor. They come in different sizes. They come with different options such as slotted floors. Really nothing magic about those. The question that I get a lot is, well, if one floor has 12% area, the other one has 15% perforated area, is that a better system? And no, the difference is insignificant. Way back when, they kind of looked at the amount of perforated area in a floor and determined that a 10% perforated area is roughly equivalent to a foot of corn. And so we're talking a matter of inches of corn when we start looking at the differences between the floors that are available. Same thing is true with vents on the bin roof. I hear a lot of questions about that. Rule of thumb is 1 square foot for every 1,000 to 1,200. And it really is sizing those vents. And I'm going to show you the picture on this next one. Some of these bins, I think they got vents growing out of them all over the place. And really, when we design the vents, what we're trying to do is reduce the amount of pressure or restriction that the air has as it leaves the, the bin. And if we're in that roughly 1,200 CFM range, that's going to be a very appropriate value. Hopper bins, again, we need to think of the same criteria that we talked about before as far as sizing, uniformity. I've seen some systems out there that um, it's amazing that they get any air through them. And so all the different aspects need to be looked at. So that brings us to the end of the slides. I do have a website that has a lot of the information on it. Just do a search for NDSU grain drying and storage, and that'll bring you typically to my website. And that brings me to the end. So I'll open it for questions and stop sharing slides.
All right, thank you, Dr. Hellevang. We do have one question in the Q&A, and please feel free to ask more questions if you have any. At the moment, we have an attendee asking, if I didn't run the fans this fall to cool grains, should I do it now?
Yes. The goal always should be to cool the grain. The one thing to be a little cautious about is that when we start running the air through the grain now, the grain will be very warm, the bin steel will be very cold. And so you have the potential for condensation on that bin roof. So making sure that we have the fill hole and the access door open would be critical. And then there would be the potential for frost buildup on the inside of that bin roof. And so a person might want to monitor that, and we've had some fairly mild days, and so maybe selecting a day and the temperatures would be, close to 20 degrees might be better than a day when it's 0 or below.
Thank you, Dr. Hellevang. We've got another question here. Is there a quick handy chart to look up days, temperature, and humidity, and would it show equilibrium moisture level at that point? If there is one, where can I find it?
On my website, I have tables for most of the crops. And so go to my website, look at the publications section, and then look for the equilibrium moisture content tables. They'll show for various temperatures and relative humidities what that equilibrium moisture content would be. As far as outside conditions, that is more difficult. um, Hopefully we're fortunate in North Dakota that we have an ag weather network, and they do measure temperatures and relative humidities. And so you can go to that website and get the information. Typically, from an aeration standpoint or storage management standpoint, I don't worry too much about the relative humidity. Primarily focus on temperature, and everyone has thermometers that they can work with. Certainly don't run the fans when it's obviously wet, humid conditions. But from an aeration standpoint, we typically don't need to be concerned about the relative humidity.
And I did add a link there for the SDSU Climate Hub for our mesonet, our South Dakota weather stations that do something very similar. So if you check the chat, I did put a link in there where you can get that information for South Dakota as well. Do we have any other questions for Dr. Hellevang? I don't see any at this time, but we do have some announcements. So before you leave, we'd like to get your opinion of today's session. There will be a poll showing up here shortly. We really encourage you to take the poll if you'd be willing. It's just going to take a couple minutes here. And then following the poll, I will give you a couple more announcements. So please hang on line just a second here. Okay, looks like most people have filled that out. If you check the chat, I have put some further information in there regarding how to find registration for more of these sessions for the rest of the week. And following this presentation, we will have an informal discussion. The Zoom link is in the chat. So if you want to join that Zoom link, Dr. Hellevang will be available and we will have an informal discussion to debrief and network. We're kind of missing with all of this online content. We kind of missed that face-to-face interaction and catching up with people. So we thought it would be fun to do a little debrief following each of these presentations. And I do have a question here about the webinars being recorded. I added in the chat as well the information where you can find the recordings of all of these webinars. They will be recorded throughout the series, and it is located at the same webpage where you register. So you'll register week by week, and in that same location, you'll be able to find the recordings as soon as we're able to post them. So that is all free to anyone interested. Just note that if you want CCA credits, you won't be able to find them without attending live. So you do need this code in the live session in order to get CCA credits. So we thank you for joining us today. I'm just making sure I'm not missing anything here in my notes. I think we've covered everything. There will be a survey at the end of each week, and you'll find that in your inbox. So if you're looking at an SDSU email on Friday, we're just emailing you trying to get further information about what you thought of the week and the new setup of these webinars. I do have one more question here. Dr. Hellevang, is there an amount of time you should run a fan once you turn it on? What is with all the wet front in bin? I'm not entirely sure. That might be a typo. But I think they're basically wondering, is there a length of time that you should have a fan running?
Well, they'll address that from a couple different angles. I think maybe part of what they're thinking of is there used to be, I guess I would call it a philosophy that once you started the fan, you shouldn't shut off the fan because you would leave some kind of front in the bin. That really was more applied to drying the grain using a natural air drying system. It was false with that scenario. And it's also not a concern when we work with aeration. When we talk about the front that's moving through, it's just the region of the bin where the temperature is actually gradually changing. So if we had, let's just say, grain at 50 degrees and we're running 30-degree air through, there would be a foot or two where the grain temperature would actually be changing from 50 down to 30. If we were to shut the fan off and start it the next day or a few days later, that temperature variation would still just be there and we would pick up from where we left off. Sometimes there's been concern, well, there'll be condensation that will form because we're cooling damp grain. And with the typical moisture contents that we're working with in grain, that doesn't occur. I've done my own research where I ran very cold or warm, humid air through cold grain, and there's a fraction of a percentage point difference, and you don't see any frost buildup. You don't see an obvious difference, and so a lot of what used to be, I think, a theory that people had come up with to address some things that were occurring, really uh, based on the research that has been done now, has been proven to be uh, not necessarily false, but not of concern. So we typically will, run the fans, whether it's an hour or 20 hours, shut the fan off and then restart it again, and there should be no problem doing that.
Okay. Well, thank you everyone for attending, and I'll watch here, but if there are no further questions, we would thank Dr. Hellevang for coming and all of you for joining in, and encourage you to check out the rest of the Crap Hour series. We'll be having these webinars at 10 a.m. every Tuesday through Friday through the end of March. You can see all of the details and register week by week on our website. The link is in the chat currently. And do look for an email at the end of the week with a survey. We'll be surveying just with a little bit more information about what you thought of the setup of our webinars as a whole and for the grain storage week in that topic. But for the time being, please join us at the Skype, or excuse me, at the Zoom link I put in the chat for just an informal debrief and some networking. And hopefully we'll see you there. If not, maybe we will see you tomorrow on our next webinar or in subsequent ones down the road. So thanks everyone for joining. And I see one new message before we go here. All right. Thank you all. Have a great afternoon. I guess it's still morning, but soon afternoon.